Welcome to More Learn, More Teach, where I attempt to simplify the complex. Today we're going to talk about probabilities. Probability is how we mathematically describe a likelihood that something will occur. A probability is the number of permutations for an event that this is the probability of, divided by the total number of permutations. A permutation is a unique set of possible outcomes. So an example here, I have two dice. A single die has the numbers 1 through 6. If I have two of them, I will have 36 different combinations if the order is important. The order is important in the permutation calculation. So if I have 36 permutations, then the probability that I will have an odd number, since there are 18 permutations that are odd, the probability of an odd number, there's 18 permutations to give me odd numbers, divided by the total, which is 36. That will give me 0.5 probability, or 50% probability. Same thing for even. Doubles. So for doubles, I have only 6 permutations that give me doubles. So if I want to know the probability of rolling a double, that's going to be 6 divided by 36, which is 1/6, which is 0.16 repeating, which is about 17%. Now that we've talked about the probability, we're going to play a little game. So in this game, we're going to roll 2 dice, and we will stop rolling the dice once we have rolled at least one of every combination. So there are 21 combinations of these 36 permutations. And as I said, we're going to roll until we get at least one of each. And we will figure out how close we were in our probability predictions. So let's watch. As you can see, we're starting to build up on certain numbers over other numbers. Getting close. All right, and we're done. The results. Now, if we calculate what the actual fraction of the totals gave us evens, odds, and doubles, we end up with a total number of rolls of 116. We had 66 that were odd, we had 50 that were even, and we had 18 that were double. So to find the fraction that were actually odd, 66 divided by 116, which is about 57%. The amount that were actually even, 50 divided by 116, is about 44%. And the amount that were doubles, 18 divided by 116, or roughly 16%. So we can see that we predicted 50% for odd and even, and 17% for doubles. We were close, but not quite there. So let's try it again. All right, so while our next game is playing, let's talk a little bit about the gambler's fallacy. All right, so the probability of this next set ending with odd, even, doubles, those probabilities are still 50%, 50%, and 17%. Even though in the last trial I had 57%, 44%, 16%, This does not mean that necessarily in the second trial I'll end up with more evens than odds just to even it out. That might be true, but it's not guaranteed. The gambler's fallacy is to put all your money now on even, since even's coming up due. Let's see how it pans out. So we can see from our second trial that we got slightly different results, right? So it took 144 tries in order to get at least one of every combination. We got 73 odd, we got 71 even, and we got 20 doubles. This gave us a fraction of 51% were odd, 49% were even, and 14% were doubles. So again, the gambler's fallacy. We expected, if I was a gambler and I was thinking that, hey, even's coming up due in order to get me my 50%, then I would expect that I'd get more, a higher fraction of the next set to be even, but that's not the case. In fact, these are closer to our probabilities than what we had in our smaller set. All right, so let's do one more try. All right, so for our third trial, it took us 76 rolls to get one of each combination. 39 of those were odd, giving us 51%. 37 of them were even, giving us 49%. And for doubles, I had 16 doubles, which gave me 21%. So looking at all three of our trials, we see that our fractions of odds, evens, and doubles are close to what we predicted with our probabilities, however, not quite there. If I add the totals I got from each of our trials, add up together, I have 336 rolls, 178 of them were odd, 158 of them were even, and 54 of them were double, which gives us 53% odd, 47% even, and 16% were double. So with this sample size, we are not quite at our probabilities. There is something called the law of large numbers, which means that if I have a large enough sample size, so if I rolled many more times, then I should see that this fraction will approximate these probabilities. So even with 336 trials, the gambler's fallacy would have caused us to lose our money. Thank you for watching my video. Please like and subscribe. If you have any questions that I can help you out with, I'd be happy to try and answer your questions. Send me an email at morelearnmoreteach@gmail.com.